Winter, 1943. A gray dawn settles over a prisoner of war camp somewhere in northern Germany. Frost glitters on endless lines of steel, fences stretching beyond sight, layered like walls of silver lace. The air is still, broken only by the distant hum of generators and the crunch of boots on frozen earth. Behind the wire, men in tattered coats stand motionless, their eyes tracing the delicate weave that holds them prisoner. It looks ordinary, wire twisted, woven, and bound. Yet each strand hides a secret, a design so strong, so deceptively simple, that no one who touched it ever escaped unscathed. Guards walk the perimeter, rifles slung low, their breath clouding in the cold. Beyond them, the wire gleams, a boundary between survival and freedom. Few knew that this fence, this unbreakable mesh, was born not in a military lab but on a civilian farm, the work of a humble fence builder whose ridiculous idea would soon reshape the security of an entire war. The story begins long before this cold morning. Long before it guarded prisoners of war, wire fencing was a quiet invention meant for peace. In the late 1800s, it marked the borders of farms, pastures, and rural homesteads. Farmers called it the silent worker, a barrier that never slept. Twisted strands of steel replaced wooden rails, shaping the modern idea of containment. By the turn of the 20th century, barbed wire had become an invisible weapon of civilization, cheap, strong, and everywhere. When the First World War erupted in 1914, this humble farm tool transformed into one of the deadliest defenses in human history. Miles of it covered the fields of Flanders, tangling soldiers in a cruel metallic web. Each strand bit into flesh, stopping advances where bullets could not. Armies quickly learned that the design of wire mattered as much as its strength. Simple strands could be cut, but when woven, layered, and twisty, they absorbed shock and resisted tools. The pattern of weaving became a science, a fusion of geometry and metallurgy. From this, a new form of barrier was born, concertina wire, named for its expanding coil. By 1918, military engineers had mastered the art of controlling space with steel. The war ended, but the lessons of wire, its ability to slow, trap, and deter, stayed with every army. In the years between wars, Europe quietly rearmed. New ideologies rose, new borders hardened, and in workshops and small factories, fencing companies continued refining their products, unaware that their designs would soon surround not fields, but men. Among these companies was a modest operation in central England, a rural fence manufacturer run by a craftsman named Harold W. Baines. He was no soldier, no engineer of war. His passion was durability. He believed that a fence should stand for decades without sagging or breaking. In 1936, Baines experimented with what he called a triple weave, intertwining 3 wires at alternating tension points. It was, in his words, ridiculous over-engineering for sheep. But the result was extraordinary. The fence resisted cutting tools, absorbed pressure, and maintained shape even when a section failed. Farmers dismissed it as too costly. The military did not. By 1939, as Europe slid into conflict again, defense officials noticed Baines's design at agricultural exhibitions. The British Army, facing the threat of invasion, required strong perimeter barriers for airfields, supply depots, and later POW camps. The triple weave mesh was quietly licensed and reproduced under government contracts. When the war expanded in 1940, wire became the backbone of control. On the front lines, it shaped trenches and defenses. Behind them, it defined captivity. From Stalag Luft III in Silesia to Camp 198 in Yorkshire, fences evolved from simple enclosures to sophisticated barriers engineered to break the human will. Still, few knew their origins. The design was credited to anonymous military engineers, but the truth lay in Baines's forgotten sketches, pages showing a spiral weave that distributed tension across every joint. To break one point was to fight the strength of all. By 1942, reports of repeated escape failures began circulating through Allied intelligence. Prisoners described fences that bent but did not break. Even with wire cutters smuggled in through Red Cross parcels, men found their tools dulled or snapped. It was not the electrification that stopped them. It was the weave itself. The pattern that once kept livestock from straying now held thousands of soldiers in place. What began as a farmer's curiosity had become an instrument of war. Yet the story of how that simple innovation reached the farthest corners of Europe from Poland to North Africa, was only beginning. By 1940, Europe was a continent of enclosures. As the war expanded, millions of prisoners were captured, soldiers, airmen, and civilians swept up by the chaos. Every power in the conflict faced the same urgent question: where do you keep them? For the Axis and the Allies alike, security meant control, and control meant fences. But traditional barriers failed under pressure. In the early months of the war, makeshift camps in France and Poland relied on standard barbed wire stretched between wooden posts. It was fast to build, but easy to cut, climb, or tunnel beneath. Then came reports of mass escapes, hundreds of prisoners vanishing overnight, aided by weather, darkness, or sheer desperation. The British War Office, alarmed by incidents at temporary holding sites, issued an order for a new form of reinforced containment mesh. Their engineers didn't start from scratch. They turned back to the triple weave pattern introduced by Harold Baines only a few years before. Across the Channel, German command had reached a similar conclusion. Under the direction of the Oberkommando der Wehrmacht, military engineers sought to create fences that could resist sustained pressure and sabotage. They studied captured Allied materials and prototypes, eventually converging on a nearly identical weaving method. 3 interlocked wires, each pulling against the others, distributing tension evenly across the structure. What made this design unique wasn't its material, it was the geometry. Each intersection carried the load of its neighbors, forming a self-reinforcing matrix. When struck, it flexed instead of breaking. When cut, it tightened around the damage. It was, in effect, a living barrier. The result was a fence that didn't just stop movement, it absorbed it. Prisoners could push, twist, or even ram against it, and the wire would groan but not yield. To the untrained eye, it looked like any other fence, but to engineers and captives alike, it was something entirely different. By 1941, camps such as Stalag Luft III, Colditz Castle, and Camp 165 in Scotland adopted the new weave in their outer perimeters. In Germany, the pattern became a standard for Luftwaffe-run installations holding Allied airmen. The same wire could be found around Italian camps in North Africa and later along the perimeters of Japanese-run facilities in the Pacific. It spread faster than most wartime technologies, not through secrecy but necessity. Every nation that faced the burden of holding prisoners recognized the same truth. Manpower alone could not maintain control. Steel would have to do what guards could not. Behind the fences, the human stories multiplied. Thousands of captured soldiers studied the wire, tested its joints, and plotted escape routes through it. At Stalag Luft III, British officers timed the patrols and experimented with cutting techniques only to discover their blades slipping across hardened steel. In one account, Flight Lieutenant Jimmy James wrote, "The wire seemed to come alive, cut one strand and it tightened like a fist." Even the guards developed a strange respect for it. They called it the Quiet Sentinel, a structure that worked without command. In reports filed by the Red Cross, inspectors noted the consistency and craftsmanship of the fences, remarking that the construction resembles fine weaving rather than mere wire stretching. Behind these observations was the forgotten civilian craftsmanship that started it all. Harold Baines's factory, meanwhile, operated in silence. His workers, unaware of their contribution to a military standard, continued producing coils of triple-weave mesh for government use. Only a handful of officers knew that the humble farm design had become official war infrastructure. By late 1943, more than 2 million meters of Baines-style fencing had been deployed across Europe. It surrounded POW camps, munitions depots, radar installations, and even airfields. Perimeters. What began as a tool of agriculture had transformed into an unseen weapon of logistics, maintaining order where chaos threatened to spill. But this evolution came at a cost. For those trapped behind it, the fence became more than steel. It was a psychological frontier. To touch it was to feel the weight of ingenuity turned against human freedom. And soon, that quiet tension between invention and captivity would be tested to its breaking point. To understand why this fence became unbreakable, one must first understand its geometry. Unlike standard barbed wire, 2 strands twisted with sharp metal points, the triple weave mesh was a network of continuous, tensioned loops. Every strand pulled in 3 directions, distributing stress so evenly that cutting one wire tightened the others. The pattern formed diamonds instead of squares, giving it flexibility under strain, but rigidity against force. Engineers described it as elastic steel, a structure that yielded but never surrendered. When stretched, it absorbed energy. When struck, it rebounded. The secret lay in balance. Tension, not thickness, was its armor. Each roll of wire was produced under strict conditions. The steel had to maintain uniform carbon content, ensuring both strength and spring. During installation, workers anchored the mesh to concrete posts and then layered a second line of barbed wire at a measured angle above it, creating a lethal combination of flexibility and deterrence. What made the system remarkable was its economy. It didn't rely on electricity, high walls, or constant manpower. The fence's very shape became its defense. The more it was tampered with, the stronger it became. Soldiers who tried to pry it apart with wooden poles found it twisting back, swallowing the gap they had made. Military engineers took pride in its design precision. Each segment could be repaired quickly, often within minutes, using nothing but tensioning tools. The modular system allowed for rapid deployment, a crucial advantage as new camps appeared across Europe almost weekly. To the military mind, it was perfection, a silent, self-regulating boundary. No alarms, no towers needed at every corner, just wire, woven so intelligently that it could outthink human persistence. By 1942, documents from both Allied and Axis engineering divisions contained diagrams nearly identical in form. The design had transcended nationality. It had become a universal logic of containment. It was not just a fence anymore. It was an idea that control could be engineered and freedom could be measured in millimeters of steel tension. But technology alone doesn't explain its power. The next angle reveals what it meant for the people who lived and dreamed of escape behind it. For the men behind the wire, the fence was more than metal. It was a horizon. Each morning, prisoners woke to its shimmer in the cold air. The mesh reflected light like a living thing, rippling with frost or rain. It was everywhere, in every direction, defining the limits of thought itself. The fence became an obsession. Prisoners studied it, sketched it, tested it. They whispered about weak points and imagined routes through it. Escape was not just defiance, it was a way to stay sane. Yet time after time, the wire broke them. At Stalag Luft III, an RAF officer recalled pressing his hand against the mesh during a winter inspection. It hummed, he wrote later, like a string pulled too tight. For him, that vibration was a reminder of the world beyond reach, of families waiting, of the futility of force. Guards, too, felt its presence. They patrolled beside it, trusting it more than their rifles. The fence erased the line between human vigilance and mechanical order. When new prisoners arrived, they rarely ran. One look at the endless weave was enough. The moral paradox was unmistakable. The same ingenuity that once protected farms from wandering livestock now confined men who had fought for freedom. The fence had no cruelty in itself. It was neutral, obedient, efficient. Yet its perfection became its sin. There were moments of grim humor. Prisoners called it Bain's masterpiece, unaware of the real name behind it. They tapped it for messages, hid notes in its folds, or hung scraps of clothing to mark passing days. It was, in its own quiet way, part of their lives, a symbol of endurance as much as captivity. By 1943, stories spread through POW networks of camps surrounded by the fence that could not be beaten. To many, it was a psychological wall more than a physical one, a mirror reflecting human limits. That sense of quiet defeat would soon face its greatest challenge, as one of the largest escape attempts of the war tested the limits of the unbreakable weave, March 1943. The snow outside Stalag Luft III, deep in Silesia, had begun to thaw. The ground softened, and with it came renewed whispers among the prisoners. They had tried tunnels before. They had forged documents, crafted compasses, sewn uniforms. Yet every plan ended the same way, stopped at the wire. This time, they thought differently. If the fence could not be cut, it could be outsmarted. In the camp's north compound, a group of Royal Air Force officers led by squadron leader Roger Bushell studied the perimeter in secret. They counted patrols, measured distances between towers, noted the wire's sag and tension. At first glance, the triple weave mesh seemed impossible. Each strand was interlocked with the next, forming a surface that moved like water when touched. Cut one section, and the pressure transferred instantly to the others. Even homemade cutters snapped before biting through. The men realized brute force was useless, so they turned underground. Using stolen tin cans, bedboards, and powdered milk tins, they began tunneling beneath the wire, planning to surface just beyond the outer perimeter, an idea both brilliant and desperate. For months, the work continued in silence. Airmen carried soil in their trousers, scattered it around the camp gardens, and reinforced tunnel walls with scavenged bed slats. Every detail was measured to the inch. But as the tunnel neared completion, one question remained: how to ensure the exit would not collapse under the fence's tremendous downward tension. To test it, they dug a small side shaft, reaching up to the edge of the inner wire. What they found astonished them. The triple-weave mesh extended below ground, anchored to buried stakes and concrete pads. It wasn't a fence, it was an integrated structure. To get beneath it meant moving earth tied directly into its foundation. Still, they continued. On the night of March 23rd, 80 men prepared for escape. Under cover of darkness, they crawled through the narrow tunnel, air stale and freezing. Outside, the camp slept. The first few men emerged, brushing soil from their uniforms. Then came the thud. The soft, terrible sound of collapse. The wire groaned, its anchors tightened, dragging a portion of the tunnel upward. Within seconds, the ground near the fence buckled. Guards heard the noise, shouted, and floodlights flared to life. The men froze in the white glare as sirens wailed across the camp. The fence had betrayed them, not by breaking, but by responding. Within hours, every escapee was captured. The damage was minimal, a few twisted stakes, a few inches of displaced soil. But the message was absolute. The fence was alive to the earth beneath it. Reports later described the failure in cold technical terms. Structural interference with foundation mesh, detected due to subsurface movement. To the prisoners, it felt like fate itself had intervened. The escape attempt that might have embarrassed the German command instead confirmed their confidence in the design. Military engineers studied the event, reinforcing their conclusion that the triple-weave mesh was not merely containment, it was deterrence by design. For those inside the camp, morale wavered. The fence, once a challenge, now seemed a sentient enemy. Men began calling it the serpent, something that flexed, coiled, and struck without warning. The failure of March 1943 would echo through every subsequent plan. The wire had proven itself, not as a wall of steel, but as a perfect expression of controlled confinement. And across Europe, word of its success reached military ears far beyond Silesia. The failed escape at Stalag Luft III sent quiet ripples through the military world. Within weeks, German engineering divisions compiled technical reports analyzing the fence's performance. The conclusion was unequivocal. No recorded breach without detection. The system had done what watchtowers and guard dogs could not. It had provided total control without constant violence. By mid-1943, the Oberkommando der Wehrmacht issued new construction standards for all major POW camps. Every new facility, from Stalag VIA in Moosburg to Oflag 9A near Spangenberg, was to use the triple-weave mesh or a direct derivative of it. The blueprint included buried anchor stakes, dual perimeter layers, and an inner trip barrier designed to entangle escapees before they could reach the outer wall. Engineers at the Heereswaffenamt praised the design as a mechanical equalizer capable of replacing manpower with metal. For a nation fighting on multiple fronts and short of trained guards, that efficiency was priceless. Each kilometer of fence could hold hundreds without requiring an extra soldier. But the Germans weren't alone in recognizing its effectiveness. Across the English Channel, Allied intelligence gathered reports of the new wire system from recently escaped airmen. British and American analysts studied sketches drawn from memory and began incorporating similar designs into their own high-security installations. At Camp 165 in Watton, Scotland, a top-secret site holding high-ranking German officers, British engineers implemented a near-identical structure, double rows of triple-weave fencing anchored by steel posts set deep in eaves. And concrete. The result was the same. No successful escapes, no breaches. The fence had become the silent signature of wartime captivity, replicated by both sides of the conflict. As it spread, minor variations appeared. The Americans introduced galvanization to resist coastal humidity in Pacific camps. The Italians wove their wire with alternating gauges to reduce material costs. Yet the core principle, tension-balanced geometry, remained untouched. In effect, the war had standardized not just tanks and rifles, but imprisonment itself. Across continents, from Poland to the Philippines, soldiers stared through the same diamond-shaped weave, identical barriers born from the same forgotten farmyard experiment. Inside the camps, the psychological balance shifted. Escape was no longer a tactical goal, but a moral statement. The fence had rewritten the equation. Bravery alone could not overcome mathematics. At the same time, for camp commanders and engineers, the fence offered something rare in wartime: predictability. It did not require ideology, propaganda, or cruelty to function. Its neutrality was its genius. It contained without aggression, deterred without blood. Still, for those living beside it, its perfection carried unease. German officers noted that prisoners became quieter, less restless. The fences seemed to absorb not only their movements, but their hope. The hum of tensioned steel filled the nights, a low metallic whisper that even guards found unsettling. By late 1944, as the war turned against Germany, some camps began dismantling outer layers of their fences to reuse the wire elsewhere. Yet even then, none dared weaken the inner perimeters. The myth of the unbreakable fence endured, a final symbol of order amid collapse. When Allied forces liberated the camps in 1945, they found the fences almost untouched. Photographs taken by war correspondents show soldiers cutting through the wire with acetylene torches, the first tools ever to defeat the mesh cleanly. The structure that had defied prisoners for years gave way only to the tools of peace. In official post-war reports, the Allies called it Type B security wire. Few records mentioned Harold Baines. His name was buried in supply ledgers and patent filings, forgotten beneath the weight of war. Yet his design had become one of the conflict's most enduring technologies, a civilian creation that achieved military immortality. And as the camps emptied and silence returned, the fences stood, perfect, indifferent, waiting to be taken down. Spring 1945. The war was ending, and with it, the fences that had defined captivity began to fall. Allied soldiers advanced through Germany, cutting open camps that had held tens of thousands. The once feared triple-weave mesh hung silent, sagging under the weight of rust and D-time. For many liberators, dismantling the fences was a ritual, the symbolic undoing of an era built on control. Photographs from Lübeck, Fallingbostel, and Moosburg show men tearing at the wire with torches, axes, and bare hands. The same steel that had resisted escape for years now folded in minutes under deliberate destruction. But even in death, the design proved valuable. Engineers quickly realized that the material could serve a new purpose. In bombed-out cities where wood was scarce and iron rationed, the reclaimed mesh became scaffolding, roofing, and reinforcement for temporary housing. The unbreakable wire that once imprisoned men was reborn as part of their freedom. In England, Harold Baines's small factory reopened under peacetime contracts. The government returned control of his patent, acknowledging his contribution to wartime logistics, though few ever knew what his wire had truly done. His workers, many of them veterans, began producing fencing once again for farms and rail lines. The same triple-weave technique remained, though its use had changed. Across Europe, hundreds of miles of military fencing were melted down, recycled, or reused, yet fragments endured. In some fields of Germany and Poland, remnants of the mesh still surfaced decades later. Rusted diamonds half buried in the soil, reminders of a time when geometry held power over men. The war had ended, but its inventions, even the quiet utilitarian ones, lived on. The story of steel had shifted from defense to reconstruction, from division to rebuilding. And still, the question lingered: could something once made to confine truly serve freedom again? In the years that followed, the world rebuilt, but the logic of the fence never disappeared. From post-war Europe to Cold War America, the principles of Baines's triple weave lived quietly within new systems of control. Architects and security engineers adopted its geometry for prisons, airfields, and borders. The same tension-balanced mesh appeared around nuclear research sites, embassy perimeters, and military compounds. It became invisible through familiarity, the steel lace that defined the modern landscape. In 1947, the U.S. Army Corps of Engineers published specifications for high-integrity security fencing, citing tests inspired by European POW barriers. Meanwhile, in the Soviet Union, state engineers developed nearly identical mesh designs for labor camps in Siberia, adapting them to withstand temperatures below -40. The wire's logic, absorb pressure, resist breach, require minimal manpower, had become a global standard. Back in England, Harold Baines retired quietly. His invention, once mocked as over-designed, had outlived its maker. When he died in 1958, a trade journal obituary mentioned him only as a pioneer in woven steel fencing. There was no mention of the war, the camps, or the millions of meters of wire that bore his unseen signature. Yet history has a way of preserving truth too. Baru function. The design survived because it worked and because it asked no questions. Today, the same mathematics shape modern barriers, from airport fences to maximum security prisons. The material has changed, aluminum, composites, electrified sensors, but the pattern remains. That enduring pattern tells a quiet story, how technology built for peace was turned to war and then back to peace again. In the calm that followed World War II, steel became a bridge, not a wall. But hidden in its design was a memory that even the most practical invention can shape the moral architecture of an age. The unbreakable fence of World War II tells a story beyond steel and wire. It began as a farmer's obsession with durability, a ridiculous over-engineering of strands meant to hold sheep. Yet in the hands of war, it became an instrument of human control, silent, efficient, and unyielding. The same fence that confined airmen and soldiers also reshaped strategy, showing that ingenuity could enforce order without violence. For the prisoners, it was a constant reminder of limits, of freedom suspended in cold air, of effort that met only resistance. For the guards and engineers, it was a triumph of logic, a tool that replaced the uncertainty of manpower with the certainty of design. And for history, it was proof that even small, overlooked innovations can ripple outward, affecting lives in ways their creators never imagined. When the war ended, the fences were cut, melted down, and repurposed. The steel that had once imprisoned men became scaffolding, shelter, and protection. The moral weight of the invention shifted from containment to reconstruction, from coercion to creation. And yet the pattern endured. From prisons to airports, from Cold War barriers to modern security systems, the principles of the triple weave persist, a quiet echo of a wartime necessity. Perhaps the most profound lesson lies not in the wire itself, but in its meaning. One person's meticulous craft had created more than a fence. It had created a boundary between hope and despair, freedom and captivity, ingenuity and morality. It reminds us that the smallest ideas, woven with care, can shape the world, and that even a ridiculous fence can leave a lasting mark on history.